Hi, welcome back to Craft Crew Math. We're here to talk about the Chapter 1 practice test, which is a mix of things like order of operations, exponents, greatest common factor, least common multiple. Let's get into it. Evaluate the expression. So we have this here, 13 minus 8, parentheses, 13 plus 9 into parentheses, divided by 4 squared. So if we're following PEMDAS, whoops, let's get rid of that. If we're following PEMDAS, the order of operations, first we have to think about what's inside the parentheses, which we have parentheses here. So we have to take care of this 13 plus 9, which is 22. I always think it's a good idea to rewrite every problem each step after you solve it. It just helps you to avoid careless errors. Next, a bunch of people would be tempted to go here and do this 13 minus 8, but that doesn't come until way later in the steps of the PEMDAS. So ignore that for now and focus on what comes next. Next is the E, which stands for exponents in PEMDAS, which is here. So we'll do 4 squared. And remember that 4 squared does not equal 4 times 2. No to that. 4 squared is 4 times 4. So that's 16 here for us. So we'll have 13 minus 8. Again, rewrite the problem to avoid mistakes. Times 22 divided by 16. Okay, keep going. What's next in PEMDAS? Well, the next level is multiplication or division. You don't always do multiplication first. You just do whichever one comes first in the problem. So again, we're still not doing this 13 minus 8 here. We're ignoring that until the end. We need to look at multiplication and division. And in this case, we're going to do 8 times 22 because it comes before the division here. So remember, whenever you have a, like this, 8 with the 22, the 8 is outside the parentheses. That means 8 times 22. Okay, remember that. Moving on. So 8 times 22. So 8, a little strategy here. 8 times 20 is 160. 8 times 2 is 16. So 8 times 22 would just be 116 plus 16. So, well, 160 plus 16. So that's 176 there. So 13 minus 176 divided by 16. Again, we're still ignoring this. Don't freak out about that. Okay, we're not trying to do 13 minus 176. We'll get there. Chill out. Okay. Next, 176 divided by 16. Okay, because we're moving on to the division part of multiplication and division here. Now, I'm not going to work this all the way out, but 176 divided by 16 is 11. So we have now 13 minus 11. See, I'm still rewriting the problem every time, which gives me all the way down to 13 minus 11. And now finally, we get to the addition and subtraction section of PEMDAS. So now I don't have any addition, so I just go straight to the subtraction. So that would be 2. There's my answer. Boom. Moving on. A square vegetable garden has side lengths of 14 feet. You plant flowers in the center portion of the garden. I got to zoom back out because I zoomed in for that other problem. You plant flowers in the center portion of the garden, a square that has side length of 4 feet, and you divide the remaining space into 4 equal sections and plant tomatoes, zucchini, onions, peppers. What's the area of the tomato section? Now, if you're following along with me, so it says, I like to draw pictures. Pictures are helpful. So it says we have a square garden here. So there's my square garden that has side length of 14 feet. So 14 feet. Doing the visual can help you keep track of things, so I highly recommend you do that. The internal part of the garden, it says there's a square. That's not quite a square, but we're going to go with it, okay? We're going to pretend that's a square. It says that it has side lengths of 4 feet, so that's 4 feet all the way around. And then it says you divide the remaining space, so that would be the space, kind of out here, right? You divide the remaining space into 4 equal sections. So let's just, cut these little diagonals here and say that those are my, again, you're going to have to pretend because I'm not the greatest artist in the world. You're going to pretend like those equal. Cut them into 4 equal sections. And then I plant tomatoes, onions, zucchini, and peppers. What's the area of the tomato section? Now, it doesn't matter that it's tomatoes or zucchini or whatever because it says that they're all the same size. So all I need to figure out is what is the area of this sort of missing part out here, and then I just divide it by 4, and that'll be the answer. So let's go ahead. So the whole square, the whole big square, this big thing here, is going to be 14 times 14 for its area. So that would be 196. And the little square would be, because it's 4 feet for its side and length, and remember we're pretending that's a square, 4 times 4, so that would be 16 for its area on the inside. So we have 196 for the whole thing, 16 for the middle part. But all we want is this. I'll use the highlighter tool. All we want is this bit that goes around the middle part. Well, how do we find that? I hope you're thinking in your head, you just have to subtract the 16 from the 196, and that'd be exactly correct. So that would be 180, right? Because it's basically like we're just cutting out this middle section here. We're not even worried about that go away middle section. So we want this 180 that's around the middle section there. Now, to find the area of the tomato section, well, now that's just 180 divided by 4. So 180 divided by 4 is 45. So that would be 45 feet squared. Next up, you are making picnic baskets. The list shows items that you are putting into the baskets. You want identical groups. That's important. I'm going to highlight that. Identical groups of items in each basket with no items left over. That's also important. What is the greatest? The word greatest is a key there. Number of picnic baskets that you can make. So everything about this problem to me says greatest common factor. Okay, so I'm trying to divide these things all into like, little baskets, and all the baskets have to have the same number of things. So like if this one, like if this one has 3 sandwiches, then this one also has to have 3 sandwiches, and this one also has to have 3 sandwiches, and I'm losing control of my writing because I'm trying to talk and write at the same time. That's difficult, but you get the idea. I'm trying to figure out how many baskets, the biggest number of baskets where I can split all those things up evenly with nothing left over. Like obviously I can't do 5 baskets because 48 apples would not go evenly into 5 baskets. You could get them into 9 apples in each basket, but then you still have 3 apples left over. So I need to find a number, again, so we're doing greatest common factor here. I need to find a number that all 3 of those numbers will divide with to figure this out. So let's go ahead and think about all the factors of 32, 40, and 48. Now, I'm going to use the, I like to call it the cake method here, and it's otherwise called upside down division. And I'm going to use this method here, and I'm going to think about common numbers that will go into all 3. So immediately they're all even numbers, so I'll put the 2 out there. Now I divide all of them by 2. 32 divided by 2 is 16, 40 divided by 2 is 20, and 48 divided by 2 is 24. And I see that they're still all even, so I can do another layer of cake and another 2. So that's why I call it the cake method, because it looks like layers of cake. 16 divided by 2 is 8, 20 divided by 2 is 10, 24 divided by 2 is 12, so I can do another one, divided by 2 again, 8 divided by 2 is 4, 10 divided by 2 is 5, 12 divided by 2 is 6, okay? So now, can I divide all of these guys by a number and still have the same number of items in each basket? And the answer here is no. So the biggest number that I can get, the largest number of baskets that I can come up with where they will all go in evenly, I just need to look at, like, so I divided it in 2, and I divided it in 2, and I divided it in 2 again. So if I go backwards from dividing by 2, that would be 2 times 2 times 2, and that would be 8. So I could use 8 baskets here. So the answer is I can use at most 8 baskets. So think about it, right? So if I had 8 baskets, then that would be 32 sandwiches divided by 8, which would be 4 sandwiches in each basket. 40 granola bars divided by 8, which would be 5 granola bars in each basket. And 48 apples divided by 8, which would be 6 apples in each basket, those are the numbers that I got down there. Look at that. So 8 is the number of picnic baskets where I can divide everything up into the 8 picnic baskets, and everything divides out evenly, and it's the biggest number of picnic baskets that I can make, because I can't do 9 picnic baskets because that wouldn't divide with the numbers. I couldn't do 10 picnic baskets because 10 would divide with the granola bars, but not 32 sandwiches or 48 apples. So the number is 8. It's the biggest number that I can use. Number 4, write the product as a power. 2 times 2 times 2 times 2 times 2. So that's, I might have said too many 2s, but that's 1, 2, 3, 4, 5, 2, so that will be 2 there as the base, and 5 is the exponent, 2 to the 5th power. Find the value of the power, 3 squared, that's 3 to the 2nd power, so remember that means 3 times 3, not 3 times 2, so that will be 9. And then again, another GCF problem, but this one is not a word problem, so that one up there was harder because it's 3 numbers and it was a word problem. GCF of 18 and 81, so that would be, I can do the cake method again, so 18 and 81. And so that would be, I divide them both by, 9 will go into both of them. So let's use 9. 18 divided by 9 is 2. 81 divided by 9 is 9. And then I kind of look at these numbers. There's nothing else other than 1 that will go into those 2 numbers. So 9 is the answer. So we're moving quickly now. 9 is the answer. So the GCF of those 2 numbers is 9. Now, if I'm moving too fast for you and you're a little bit confused about what GCF is, remember GCF is I'm trying to find the largest number, the biggest number that will fit evenly into both 18 and 81. Like I can do 18 divided by 9, and that will give me an even number is the answer. I can also do 81 divided by 9, and that will give me a whole number, not an even number. It will give me a whole number as the answer. Okay, so I'm trying to find the largest number, which in this case is 9, that can evenly divide with 18 and 81, right? So that's where we're going. Like I could have done 3. I could have done 18 divided by 3, and that would be 6. And I could have done 81 divided by 3, and that would be 27. But 6 and 27 can still be divided again, both by 3. So if I can divide them again, like I did here, I divided them the first time, and then I divided them again. If I can divide them again, then that's not the greatest number that will go into both of them. Because once you use the greatest number that will go into both of them, you'll be produced, like the thing that gets produced will be 2 numbers that nothing else will go into except for 1. So that's what makes it greatest. It's the biggest number that goes into both of them. All right, now on to least common multiple. Least common multiple is it's not the opposite of greatest common factor, it's related, but instead of thinking about smaller numbers that will go into the 2 numbers, like 18 and 81, we're thinking about larger numbers, like if we were skip counting by the 2 numbers, 6, 12, 18, 24, and on and on. We're trying to think of a number later on, if you're skip counting by both of the numbers, that they would both meet at some point. So like in the case of 8 and 6, if I skip count by both of them, they both wind up hitting 24. Now they can keep going later on, and they would both run into like 36 and then 42 and then 48. They would both hit 48 also. So it'd be 32, and then I'm just checking my math on the counting by sixes to make sure it's right, and this is 40 and then 48. So they would also both hit 48 if we were skip counting by both numbers. They both have 48 on the list, but 24 is the smallest number that they both have on their skip counting list. So 24 is the LCM for this problem. It's the least common multiple. It's the least number that they both share when you're counting by them. It's the least common multiple. Next, determine whether 110 is a perfect square. Well, remember, a perfect square is a number like 100, where you can do one number multiplied times itself, and it will produce this number. So 10 can be made by a number multiplied by itself. Can 110 be made by something multiplied by itself? The answer is no, it cannot be made by a number multiplied by itself. Sometimes students will get confused and they will think, well, Mr. Kraft, we can do 55 plus 55. But again, remember the key here is multiplying. The numbers have to be multiplied together to make the larger number, not added together to make the larger number. So 100 is a perfect square. 110 is not a perfect square because there's nothing that multiplies by itself and is a whole number to make 110. Next, which power has a value that is greater than 510 and less than 515? Okay, let's take a look at this. Greater than 510, less than 515. Well, you just kind of have to multiply out all of the powers here to figure this out. So 7 times 7 times 7 is 343, so it's not this one. 22 times 22 is 484, so it's not this one. 8 times 8 times 8 is 512. Is it that one? Looks like it is. Let's do 4 to the 4th power just to be sure. 4 times 4 times 4 times 4. That's 256. So it's not that one either. So it's this one, 8 to the 3rd power. You just got to evaluate all the powers and pick the one that falls in between this range of 510 and 515. Number 10, identify the factor pairs of 28. So when we talk about factor pairs, we're talking about numbers that will multiply together to make 28. So if we're thinking about that, well, we should always start at 1 because it's a logical place to start when you're starting with numbers. Let's think about 1. So does 1 multiply to make 28? Well, yeah, of course it does. You can do 1 times 28. Now what's next after 1 is 2. Does 2 multiply with something to make 28? Well, yes, it does. 2 times 14. 3 does not go into 28, but 4 does. You can do 4 times 7. 5 does not go into 28. 6 also does not go into 28, but 7 does. But 7 is already on there, right there. So I don't have to do 7 again. And it turns out that once you get back to a number that you already had listed, you're finished. So these are the only 3 factor pairs of 28. So I just got to go on my list and find them. So here's 1 there, and 2 and 14. Where's 2 and 14? Where is it? Y'all probably see it on the video, and I can't find it. There it is, 2 and 14. And then we have 4 and 7 there. Those are all the factor pairs that make 28. Moving on. Identify the prime factorization of 360. Prime factorization, that just means I'm going to write out 360 as a product of a bunch of prime numbers. So all prime numbers multiplied together. That's what product means. So I'm going to use a factor tree to help me get to that. So 360, let's break it down. So I could do 36 times 10. Neither one of those are prime, so I break it down farther. So 36 is 6 times 6. Again, neither one of those are prime, so I'll break it down farther. So we'll have 2 times 3. And 2 times 3. Now, all of those numbers are prime, so I'll put them in blue so I remember that they're my prime numbers. And then I'll go back up to this 10. And 10 will be 2 times 5, and both of those are prime as well. Now I don't have anywhere else to go, because everywhere I go down the tree, I eventually will get to some prime number if I follow all the branches. Look. So, like, eventually I wind up at some prime number. So now I'm done. So that would be 360 equals 2 times 2 times 3 times 3. Oh, there's another 2 with the 10. So 3 2s, 2 3s, and a 5. 2 times 2 times 2 times 3 times 3 times 5. I can combine those 2s to be 2 to the third power. I can combine the 3s to be 3 to the second power. And then there's just one 5, so that's times 5. Now, if I look over here at my options, boom, this one right here, this guy. 2 to the third power, 3 to the second power, and 5. I know it can't be this one because 10 is not a prime number, or this one because 45 is not a prime number, or this one because 9 is not a prime number. So I guess if I would have just looked at my options first and not worked out the factor tree, well, then I guess it would have given it away, right? Because of all the things that are not prime numbers in those. Number 12, what is the greatest perfect square that is a factor of 180? Well, okay, so remember that a perfect square, we talked about this a little bit earlier in the video, is some number multiplied by itself that makes a larger number. So 180, I'm going to break this thing down into its prime factors, and you'll see why in just a second. But I'm going to find the prime factorization of 180 here. So that would be 2 times 2 times 3 times 3 times 5. Is that also this one, this one, this one, this one, this one? Yep, that's right. So 2 times 2 times 3 times 3 times 5. Now remember, a perfect square is a number multiplied by itself. So here's a perfect square, and here's another perfect square, right? So this would be 4, and this would be 9. And when I multiply 4 and 9 together, they make 36. And 36 is another perfect square because it's 6 times 6. Now, if you're having trouble seeing that the 4 times the 9 makes a perfect square, well, what if I, took 1, 2 and 1, 3, and I said 2 times 3, and I took the other 2 and the other 3, and I said 2 times 3. So I had 2 times 3, which is 6, times 2 times 3, which is 6. So 6 times 6, which is 36. Either way, you wind up getting to 36. So it turns out 36 is a perfect square, and 36 is also a factor, because here it is, 2 times 2 times 3 times 3, of 180. So the greatest perfect square that will go into 180 is 36. And prime factorization, I've been highlighting in blue. Let's go back to blue. Prime factorization makes it easier to see that. So that was a challenging question, so I didn't really expect very many people to get that correct. And those of you who are in my math classes and took the test, you struggled with that one. So I mean, that was a hard question, so it's okay. Number 13, a tank in the shape of a cube. A tank is in the shape of a cube with an edge length of 6 feet. So again, I'll just draw my picture here. This is my cube. So pardon my lack of artistic ability. Here we go. This is a cube. This is a tank that's in the shape of a cube with an edge length of 6 feet. I'm only going to label one side because cubes are the same size all the way around. Find the number of cubic feet of water needed to fill the tank Then find the number of cubic yards of water needed to fill the tank. So this question it's a little tricky because it's setting you up to do cubic feet and then do cubic yards. And now, well, we're going to do cubic feet first, and then we'll come back to cubic yards in a second. But so volume of a cube is just the side length cube. That's why it's called a cube, because it's just the thing times itself 3 times. So that would be 6 times 6 times 6, which would be 36 times 6, which I think is 216. Let me work that out real fast. So it's 18. Carry the 3. Yeah, so 216. So that would be 216 cubic feet for the volume of the tank. So that's one answer. But what about cubic yards? Now, a lot of you are probably tempted to say, well, I know that 1 yard is equal to 3 feet. So if I need to convert this 216 to yards, then I'll just divide it by 3, right, Mr. Kraft? Wrong. No. Actually, what you need to do, you guys, is before you work out the problem, you should convert the 6 feet into yards, right? So this would be 2 yards here instead of 6 feet. So you change the 6 feet into 2 yards, and now you find the volume of the cube with 2 yards as the side length instead of 6 feet as the side length. So the volume then would be 2 times 2 times 2, which produces a completely different answer because it would be 8 yards cubed. It produces a completely different answer than 216 divided by 3. Okay? So, now, why does that work? Well, here, you guys, when you multiply the 6's together, you're multiplying the 6 together 3 times, right? And down here, when you divided by 3, you only divided by 3 one time. Really, you should have divided by 3 times because you had to multiply by 6 3 times. So every single one of these 6's has to get converted into yards if you're going to properly convert it into cubic yards instead of cubic feet. I hope that makes sense. But the easier thing to remember is just, this is looking really messy, so that's great. This is great YouTubing, you guys. One of the things that's easier to remember is just to go ahead and convert your whatever you need to convert it before you work out the math, and then that will make things easier. So we wind up with 216 feet cubed and 8 yards cubed. So remember to convert before you multiply, save yourself some trouble. And the last problem, stoplight A changes color every 30 seconds. 30 seconds is important. Stoplight B changes every 40 seconds. Both stoplights changed color 20 seconds ago. A lot of people got tripped up because they didn't see this 20 seconds ago. After how many seconds will the stoplights change color at the same time again? Well, this is a least common multiple problem, right? Because one stoplight is going every 30 seconds, and the other stoplight is going every 40 seconds. And we're supposed to figure out when they're going to change colors at the same time. Well, it turns out that the shortest distance between those two numbers is 120. So they'll both change colors at the same time after 120 seconds. Every 120 seconds, the lights will change colors at the same time. So you might be tempted to just put 120 seconds here as the answer, but that will be wrong because notice the problem says that it just changed 20 seconds ago, right? So if it changes at the same time every 120 seconds, and 20 seconds have already gone by, that means the next time that it will change at the same time is not 120 seconds, it's 100 seconds because 20 seconds have already ticked off the clock. So minus 20 here, minus 20 here, they would both be 100 seconds until the next stoplight change. Okay, you guys, that is the practice test. I hope that this video was helpful. And if you liked it, go ahead and click like. You can subscribe to the Craft Crew Math YouTube channel if you want to. And tune in next time for more